we live? Okay, we are live. Okay. So welcome everybody to one of the SEAM hosted talks. My name is Andrew. I will be your host and moderator today. And today it brings me great pleasure. Before I begin, I'd like to acknowledge the traditional owners of the land on which Swinburne's campuses is on. We acknowledge their elders past, present, and emerging. Today it brings me great pleasure to actually introduce one of my former bosses or collaborators in Singapore, and I've got Chris here also, who everybody knows the director of SEAM. Today I have my pleasure to introduce Professor Michael Khor, and I've known Michael for for about 15 years or more from Singapore. And he actually did his PhD in Monash under Professor Reggie McPherson. And as I mentioned to Sam just now, he actually worked at CSIRO before returning to Singapore. These days, Professor Khor is actually the Director of Talent Recruitment and Career Support, all right, at the Office of Bibliometrics Analysis at NTU. And he's also the professor at the School of Mechanical and Aerospace Engineering. I won't read out everything that Prof. Khor has done, but I would like to sort of describe Prof. Khor to me when I was a young undergraduate, when I first met him. Very well respected, over 30 years in the surface coating industry, and then he got the privilege of serving as the director of our National Research Foundation, which meant the students got to run the lab without the director without the bell boss being there, and that was exciting times. I learned a lot of how to fix things by restarting or kicking the computer. But you know, today Prof. Khor is going to speak about a topic that's close to his heart, and probably tell us a few different tips and hints about future success. The talk is titled Early Career Researchers and Indicators for Future Success. Prof. Khor, please.
Thanks very much, Andrew, and it's really a great pleasure to share with you the findings in this presentation. So early career researchers means anyone who has finished his PhD and perhaps into the first 1 or 2 years post-PhD. So obviously, you know, this, whatever that I'm going to say this morning doesn't apply to Chris. So, but to the rest of you, I hope it has hopefully something valuable for your future career, because you're going to have, you know, another 40, 50 years ahead of you. And so what I hope to show this morning are examples of successful researchers who started publishing only in the 2000s, in the 21st century. So hopefully you will be able to identify with these authors that I'm going to share with you. So we know that today, the early career researchers are the majority research workforce in the world. Right? Anywhere you go, any university labs you step into, the people in the lab, on the bench, in the spray booth, wherever, they are all young researchers. And if you were to ask them, what is your #1 career choice? Easily 75 to 80% of them would say the academia. I want to be a professor. But we all know that there's limited vacancies. And today, thankfully, we are seeing diversification of the global research enterprise. There are more and more options opening up now for PhD graduates. So it's no longer just academia, but now you have industry, you have government research institutes, you have government agencies. So more and more ministries, government departments are seeing the value of a PhD training. So it can be, someone trained in physics, but then get employed by the department involved with trade and industry, or transportation, or manpower, and of course scientific publishers are hiring PhD graduates as well, because they know what publishing is like. And I should also include among the options research administration, those who run the research office, run research grants, and so on. And it is very important to offer these career options, career pathways, if you like, to PhD graduates, simply because otherwise there'll be the danger of high attrition rate. And we will lose many of these despite the university training to some other industry, which will be a loss to research. So I basically put this up as a summary of what I just talked about. So for early career researchers, which means all of you except Chris, there are two pathways. So one, research, which I just described, and two, non-research. But these are also very important because it also involves, scientific equipment and infrastructure, the sale of it, and people handling the management of it, servicing of it, and so on. So early career researchers are indeed the future of global research. We all know, besides the pandemic and the worry about disease X, there are other global challenges facing us, which I've listed here, and this is by no means the only ones. There are a lot more. And the early career researchers are the ones who will be working on this actively and also contributing real valuable solution to all this problem. It will not be people of my generation, right? And it requires a different way of looking at the problem. So at NTU, we saw the importance of early career researchers and trying to nurture them for the next phase of their career. And so in 2018, we started the NTU Presidential Postdoctoral Fellowship. And this is a 2-year fellowship which provides the awardees independent research. So no longer will they be working under someone, under the supervision of someone. You will have the independence to run your own program for 2 years, and also have the benefit of having mentors in the host department as well as across the university's ecosystem. And we've got on board as well either high net worth individuals or corporations to provide endowment to this scheme so as to provide additional aspect to it. We have also used this scheme to link up with foundations overseas. And this is an example. We have the Wallenberg NTU Presidential Postdoctoral Fellowship that looks into some of the very key areas of 21st century, such as AI, machine learning, data analytics involving huge data, software security. We all know the importance of cyber security. Definitely Optus does, for sure now, right? And of course, future mobility, autonomous vehicle. There's already 2 cities in China that are trialing these autonomous vehicle taxis, Wuhan and Chongqing, and there'll be more of this in the days and years to come. So here are some of the key questions, and I'm sure there are a lot more. How severe is the COVID-19 impact on the development of the early career researchers? So imagine that if your chosen field of research is earth science, studying either earthquake or volcanoes, or marine biology, you cannot travel at least in the first year of COVID, but of course in Australia it's longer than that, especially if you're in Melbourne, but that's all in the past now. I hope everything is now forgiven. But you know the kind of impact that it has on the development of early career researchers. So this is a tremendous challenge to the universities. Also, how to ensure progress in an increasingly competitive environment. How do you ensure that the early career researchers do get to go on to the next phase of their career, wherever it may be? Apart from academia, it could be industry, it could be government agencies, scientific publishing, and so on. So today, I'm basically just going to answer the final question. And I don't recommend it as a strategy for exam question where you answer the last question first, but I'm going to do that this morning. I'm going to tackle the final question that you see here. What are the indicators of future success? We all know what you do today determines what you will or who you will be 5, 10, 20 years from now. The choices that you make, the decisions that you make, really impacts, what will become many, many years down the road. So what I'm going to offer this morning is basically a bibliometric analysis of top researchers who published their first papers in the 2000s. So whether it's 2004, 2001, or 2010. And I'm going to focus on just 3 subjects. The third one is not really a subject, but it's probably interdisciplinary kind of topic. But material science, computer science, I hope to show some examples. So I base the selection of the early career researchers on a composite score put up by John Ioannidis in Stanford with his colleagues, including Kevin Boyack and Dick Clavans and others who work in this space. So this composite score basically takes into account so it's a citation-based measurement. So they take into account the total sites, the H-index, the H-index of multi-author paper. So whether the number of authors in the paper is 300 or 3,000, that has to be treated differently from papers that probably only have 2 or 3 authors. Then you have total sites of single author paper, which doesn't happen in surface engineering, I know, but perhaps for economics or mathematics where single author paper are highly valued. And then whether the size is for for single plus first author paper, or whether the person is a first or the last author. So these are all important factors. We're going to start with material science. And by looking at a certain cutoff threshold, and 3.4 is pretty high up in the list of. We picked up the following distribution. Highest number in China, followed by US, and the rest you can see. There is one in Singapore, but that's not me. So, but you know, you can see a diversity of countries with this promising young authors. And then we look into it a bit more deeper. So which institutions do they go to, or do they belong to? Turns out that you know, there are not that many of them belonging to the top 50 universities. So it means that the top 50 universities in the world for material science do not have you know, that many of these top young researchers. They do have some, especially University of Michigan, Ann Arbor, and maybe Caltech and the rest, but not that many, right? So it means that the world global ranking is not a critical factor. So the top universities do not have a monopoly of the top talents in material science, which is good news for, you know, for this place, right? Okay. Then we go on to the top researchers, and I pick up the, you know, the top 25 or 30. And again, you can see that out of these, there are only 2 belonging to the top 50 universities in the world. The rest you can easily see are not quite at the top, but they are all very good. And we're going to look at one of the top. I picked up Professor Paulo Davin from University of Aveiro in Portugal. And we're going to drill down at his you know, publication and collaboration. And turns out that the number of authors that he has multiple papers with, you know, apart from Portugal, are mainly in India. In fact, the top 3 are from India, right? And then Spain, which is a bit strange for Portuguese, but anyway. Then after that, India and so on. So looks like he has a lot of connection with Indian institution. Also, very importantly, and this is one of the key points I like to make in this talk, is that top researchers oftentimes work with other top researchers. And I could find, you know, at least 10 of his co-authors who also belong to this elite group of researchers belonging to the top 2% of authors in the world. And they're from very different countries, right? And only one from US. And from the look of the name, he's Turkish. And this is his collaboration map. And more importantly, what is it that he's working on that makes him a top researcher, right? Although it is listed as material science, but looking at the keywords, it is more of at the interface of manufacturing engineering with materials. So what is it that made him, you know, famous or prolific in a way, is that he found some fundamental technique as well as understanding on the machining, if not the turning or drilling of this materials laminate. And he studies the delamination of materials when it comes to, and the key thing is that he relates surface roughness with the drilling and turning efficacy and effectiveness, and that's what elevated him to the level that he is in today, right? And once he has got that something really fundamental, then he could then go on to apply it on metal matrix composites, on magnesium, on various, and there are many associated studies to go along with it. Then we go to another example. Sivalak is from Turkey, and he is somewhat different from the first example because in Davin's case, his collaboration is very international. Asia, Europe, America to some extent, but quite wide. But here you find that for Sivalak, it's within this locale, his region, Middle East, mainly Middle Eastern, or in fact, predominantly Turkey, but then involving Iran and a lot of Iranians, and then and some Egyptians as well. Again, among his co-authors, we do find quite a number belonging to that elite top 2%, right? But also, as with previous case of Davin, you'll find that he has an anchor co-author, someone who, perhaps a senior that he works with a lot in his own university. So where he is, and it doesn't matter if it's not a top 50 or a top 100 university, as long as there is someone that he can work with and that the environment enables him to carry out the work, he can actually then go on to publish great results. And this is his collaboration map. You can see it's mainly regional, and later on you will understand why is it that he has that linkage with Taiwan. Turns out that what he's working on has important application in medical field. And so the Chinese Taipei University of Medical University in central Taiwan got him over as a visiting professor. And so at first I thought he was, in Taiwan, but actually he's in Turkey. And so you can see, so he was able to study the vibration-free buckling of micro beams, which you can clearly see or can quite easily see the application in surgical tools and all that. And it also involved laminated composites and microtubules and so on, right? So the third example from material science is someone in Australia, Newcastle. So this guy is in Newcastle. His main collaborator, his anchor collaborator, if you like, is in Japan. And he has strong collaboration across Australia, mainly his own home university of Newcastle, but then he has other collaboration with co-authors in various parts of the world. And again, many of his co-authors are also found in the top 2% list. And so they are all top authors themselves. And he seems like a very busy guy, which he actually is. And you can see from the map that he collaborated very actively. And later on, when I show you the map of the keywords, you will understand why. So he collaborated a lot with Japan, with India, South Korea, and also Saudi Arabia. So, okay, so he worked on mesoporous materials. That's the key for him. He was able to get into a certain aspect of the mesoporous materials and then engineer it for application as heterogeneous catalysis, various aspects of catalysis, in fact, and then going on to then work on with people on absorption phenomenon, CO2 absorption, which is important for environmental, interest, and so that led on to a lot of possibilities. So from one important, or maybe a couple of important breakthrough, he was then able to extend it further into other applications. So 3 examples in material science, quite diverse, but there are common observations in each of these. We shall now move to another subject, computer science, which I don't know a lot, but just a little bit, enough to at least share some of my observation with you. So here in computer science, the order of the first 2 countries change. So it's US with the highest number and easily twice the number of the next country, China, followed by Great Britain, and then Germany, France, Taiwan, Australia, and so on. Quite well distributed, and you can see that Singapore is also well up in the list. And then when we look into the institution, you see the top is CMU, well known for computer science, so no surprise there. But what I do find is that you have Google, Microsoft, Facebook. They are in there, and they are among the top, and they are the ones with top young talents. Not surprisingly, because they're always looking into the future. So they invest in the young, and among these top institutions with at least 5, again, you don't see that many in the QS top 50 university or top 100 university. CMU has dropped to 52. It was in the 20s, but it has dropped to 52. But to be fair, if we were to expand the analysis, down to minimum number of 1 researcher, then clearly the top 50 universities in the world, according to QS, do have these young talent, but just not in great number. 1 or 2 is the most common, and rarely go beyond 5, except for Stanford. And we all know why Stanford is there, because Google is next door, as well as other high-tech startups. So not surprising, right? Of course, Stanford is not that far from Napa Valley as well. Okay, let's look into the top researchers, right? Top guy, we're going to look into him in a short while. We're going to look into someone else from Facebook, and then we're going to basically stop there. But you can see from the list that in this case, 6 are from the top QS ranked universities. But again, these top ranked universities are not among the majority, although more than material science. So first guy, Ren Wei, he collaborates mainly with colleagues in US, but actually a lot in China, right? So I suspect that he's originally from China, and when I look into his background, he got his basic degree there, and then he moved over to the States, and then not surprising that he continues to collaborate with China. and Chinese, I should say, because if you look at all the names, you know, it's all Chinese except for the guy from Brigham Young University, you know, but he probably have a Chinese mother, who knows? So anyway, you know, this is a side observation as well. Again, you'll find that he has an anchor, probably two anchor collaborators, and many of his co-authors are in the top 2% as well. So again, the same point that I made early on. Top researchers work with other top researchers. So that's key. And this is his collaboration map. Country-wise, not that many, not as many as material science. And what was important for his work is cooperative control. So basically, why his research is so hot is because he's got an algorithm, he's developed algorithm that enables cooperative control in multi-agent setting. It's like 5 of us onto something common, and each of us have a say in and can have simultaneous input into what's going on. And apparently that's important. And not only that, but there is consensus built into it. Meaning to say that we're all 6 or 7 of us working on something, and then we've got to agree. If someone would say, hey, let's get this done on this and all that, there must be consensus. And somehow it's able to build that consensus aspect into it as well. So there is cooperative control, and that enables a lot of people. So basically, it's like he opened the door for others to go in. And that, again, is a very important aspect of research. So research that has great impact are those that open doors or provide pathways for others in his community to go into. Now that's important. Right, let's go to the next guy. And I only have 2 in computer science. So not surprisingly, Gershwin worked with many other people in Facebook. Full of talents there, but of course he also worked with collaborators in UC Berkeley, and mainly it's US based, right? So this is very US based network, and just like the past examples, he has co-authors, many co-authors who are also in the top 2% list. This is his collaboration network, and the collaborating countries, not that many, mainly in US. And then his claim to fame is more in graphics visual, right? So it's on object detection, and then in real time. And basically this is, you know, very fast real-time object detection, which I believe it is important for the gaming industry, video gaming and so on. Those games in Xbox and PlayStation, which I don't touch. Yeah, so sorry to keep you waiting for so long, Chris. I know that you're waiting for this to come on, but you know, yeah, patience is a virtue. So I'm going to round up my talk by sharing again some observation, but it's different from the ones that I showed before. So this is about intergenerational research, how from one generation it goes to the next generation. So this is another theme that I'm working on in my research. So surface engineering, focusing on plasma spray, looking at authors who started publishing in the 80s. And then I look into another group of authors that start publishing in the 90s. like me. And then the authors who started publishing in the 2000, like Andrew. And I'm curious to learn how each of these generation connects, interact with each other. Of course, we also look into the dynamics of a transfer of expertise and knowledge across the world, especially when you have students from certain part of the world coming over and in the 80s, it was the US, learning about the technology and bringing the know-how back to their country and then developing the technology there and so on, right? And so we have quite a rich network map featuring the key people whom I'm sure Chris recognized a lot. All these blasts from the past, but you know, these are the network that they have. Then, of course, in the 90s, it became even busier, and more countries are added to this. Here I'd like to point out that not all are purely into the surface engineering aspect of it. Brasinis, for example, is more of a mechanical engineer who look into the flow dynamics, right? And then there are others as well who basically look into different applications. Then the 2000. So the 2000, I decided to put a time bar on it. So the blue, the dark colors are those that started in the 2005, and then the yellow is in the 2020 and beyond. And here you can see that the network is more dominated by a certain big countries, which I shall not name, but I can tell you that they all speak Chinese. So, so that's the situation, right? Then I decided to then look into having this time series and then apply it onto the previous map that you saw. So again, you see the familiar name who started publishing in the 80s, like Sanpav and others like Bulos and others, Katikayan as well. And you can see that apart from Sanjay, there's not a lot that actually have the yellow dots next to them, right? Maybe you could say Kumar probably has that, but more so is among the Chinese names like Liu, you know, and CJ Lee, obviously, that has that kind of coloring onto their. Whereas if you look at the darker colors like Luke Scheider or Smith, you don't see that transfer happening. So that brings me to my final point on intergenerational network. So looking into Chris here, his connection with Sanjay. Clearly, this is people who work in a common space. So this is the NSF-funded thermal spray lab. And here is a further elaboration of Chris' network, you know, involving his students. You see Andrew here. Andrew is green, whereas Lima is darker color. And this is a representation of the intergenerational. That means it's a researcher, active researcher, having a connection with different generation. You see that also in Sanjay Sampath. And in his case, perhaps a bit more dense because of the center. So the role of the center is crucial. So you see a nice mix of colors from yellow to cyan and so on, all the way down to magenta. Oh, summary. What have we learned so far? And this is, you know, for me, it's testing out these ideas on studying early career researchers and trying to understand what are the likely indicators for future success. So from the cases that I studied, we find that ranking of the university is not a key factor. You don't have to be in a top rank university to be a world-class researcher.
We know that at Swinburne.
Okay. Right, so it is the people and the support that the organization give you that will help elevate you. So, you know, but do consider NTU though. Ranking of university is not a key factor. The top young researchers tend to have extensive local, so within their university, but if they cannot find it, they will look regional, if not then international, right? So they basically are active in forming network. They are actively looking for collaborators. And I'm sure they have a system to filter out, right? The weaker ones from the strong ones, and those, it's a bit like dating process, right? So, so it's a kind of same dynamics, but different results, I'm sure, outcome, I mean. So they collaborate with other top authors, and oftentimes there is an anchor collaborator, someone there working hand in hand. And this is important. My first point here is very important for those who are pursuing PhD and into their first year or so in postdoc. You have to think and you have to look for fundamental research that has important ramification, not just in your field, but beyond. Because from the examples that I share with you today, you'll find that when you have that fundamental breakthrough, it will have broad appeal. So you must have something that potentially will have broad appeal. People from different fields will want to know more about it. And that's what Nobel Prizes are given out. Think about graphene, given out in 2010 to Novoselov and Gaim. You know, once they come out with graphene, you know, other industry benefited from that kind of 1D and now 2D material, right? So this kind of breakthrough in fundamental research with broad appeal is essential to catalyze future success. Then the sustained success is done through a widening of collaborations. So attending conferences, and not just within Australia, but overseas, across the world, is so important. So you must have organizations and centers and directors that support you to go, you know, to many, many places in the world. And then there is this role of intergenerational research in a center, such as SEAM, because there is indeed benefits that you can get, and such as sustainable development of technology and innovation, which brings me to my final slide. And that's what SEAM is, how I see SEAM as well, where you have SEAM as an ARC training center, focusing on surface engineering for advanced materials, and that's what SEAM stands for. And my hope and wish is that you could see form a very vibrant mapping of key authors in the not too distant future. So thank you very much for your kind attention.
Thank you. We'll take a couple of questions from the audience and also online. Sam, would you help to read out or anything online? Okay. Oh, Surinder will do that. First question from Ashok. I'll pass you the mic so that people online can hear you.
Thank you, Professor Khor, for this talk. This is quite different from what we always see. Yeah, my question is, did you consider patents in your calculations, like to find out the top researchers? Because this is all about publications, but patent might be a different things when we consider as a researcher also that how because patent is like new technology coming out rather than just working on the publication. So did you consider that? And it was interesting to see that in computer science, there are a lot of industries which are also in the top, but when you go to the material science, it's just like no industries or nothing like that. So does it give some other stories to us? Do you have any thoughts on that?
Okay, yes, and thank you for your question. So obviously, materials industry is different. The path to application and commercialization is somewhat more convoluted, let's say. And if the person happens to work in an organization like Facebook, obviously it's even clearer. But yes, pattern is key, and that is the study that we are currently working on. Yeah, and in my next presentation, hopefully I'll be able to share some insight into this. But clearly, from what we have seen so far, yes, there is that link. And in NTU, we have not just the Web of Science, but we have Derwent as well. So it enables us to kind of link publication with pattern analysis. And that's very powerful because in Singapore, with the government's 5-year plan and the 2025 plan was launched just over a year ago. And more and more emphasis, we can see more emphasis is given to translational research. So the need to push research breakthrough out into the market is important, at least, be on the journey. So yes, clearly that is in the works, and that's in our consideration to study that. Yeah.
Thank you. Any other questions from this side? I know Chris got a ton of questions. I mean, anyone online? No online questions? Chris, do you want to?
So, most interesting. How does a university implement what you've just described to try to attract an ECR to their university? How do you implement the knowledge that you've gained so that the university, whatever, can attract that ECR? How do you go about doing that, Professor?
Oh, very good. That sounds like an interview question, but anyway. But so here again, and that's a very important question. Thanks, Chris. So I've got a lot of questions coming from the ECR to me, and that's why I feel that I'm able to share a little bit about what they're looking for. They're looking for the support structure. They're looking for the kind of setup that they believe that they are able to thrive in. So so I know that for those who so we're talking about those who are in the top, right? So not just anyone just desperately just wanting a postdoc position. So these are people who probably have 5 or 6 openings which they can pick and choose. And so why do they choose, say, NTU, right? So from what I learned is that they made a few inquiries. They got to know some people there. They got to kind of like, and maybe it's 1 or 2 degree removed, but nonetheless, they have common connection so that they have reliable information coming back to them about the place. All right, they learn about how, what's the lab culture like, what sort of support structure is like, whether they just, the department just don't care or they do. And then they observe the outcome, friend of a friend who've been there, and how did they do? What do they, And then also the possible connection that they can make. And again, this is something that I observe. The smart students or the smart researchers will always think 3 steps ahead, not just the next step, but they are 3, 4 steps ahead. So they're always thinking, so if this is going to happen, then what about the next? And what about the next? They're always asking this kind of question to themselves and to the organization. And that's the people we want as well. We want people who are able to, even before landing in NTU, are able to see the potential connection that they can make with this person, with so-and-so, and with the other so-and-so, right? And they got to be able to have that assurance, if you like, before they make that commitment to want to come to a place like NTU or Swinburne, I'm sure. So it is that kind of knowledge that you have the equipment to support the research. It's not like, maybe we'll get that next year. Or maybe, the grant, if the grant falls through, yes, we might be able to get that. No, that is not the way. They want to be sure that the moment I land, I have this support, I'm able to do this, and I know so-and-so, and I know so-and-so, and usually these are people of their age, probably around the same age band. And one thing I observe about the ECR is that ego seldom gets in the way, because when you are ECR, ego is like this. It's only when you become a professor then the ego is like this. Right? Oh no, like this. So oftentimes ego gets in the way of collaboration. But I find that with the ECRs in NTU, it's easy for them to make collaboration because it's a very straight, direct line, without a lot of other considerations.
Thank you, Prof. Khor. Any other questions? Else, I'll ask my difficult question. This question is the sort of, I don't know whether you get this question, is twofold. First of all, how much in terms of metrics is being used, for example, to evaluate applicant for the 2-year postdoc fellowship at NTU? That's one fold. The second fold question is then, we hear a lot about open source publication and also publications in high impact factor. So would you recommend someone to go for number or to go for impact?
Okay, yeah, that's very important. So to start with the first question, we know that the 2 years is for them to have a head start. And hopefully those 2 years is a very powerful launch pad or a springboard for them. But a lot more has to be done beyond the 2 years. So beyond the 2 years, where will they be? Will they still be in NTU, or will they move overseas or elsewhere in Singapore? That we don't know, and that is an ongoing study. So you just described the sort of thing that I'm studying on a day-to-day basis. So we have a nice tagline for the office: tracks. We track the ECRs. who have passed through our gates in a way. We want to know, where they go to and whether they have been successful or not in the next stage of their career and so on, and as long as possible. That's what we do. And hopefully the research grant that NTU provides for the 2 years as presidential postdoctoral fellows will be that important fundamental breakthrough that we saw in those examples that I showed you, that will then be the stage on which or the platform on which they build their future career and future collaboration that they have. Yeah. And sorry, your second
question relates to how applicable publishing many papers is
better. Okay, yeah. So quantity versus quality. So I again, this is just on how some university administrators review application. And something about the human mind. The human mind is made for numbers, like it or not, right? 5 is somehow better than 2, and 15 is better than 9. The human mind is built that way. Yeah. Yes, but I do know that at the high level, they're able to, kind of immunize themselves against that, and they then look into the deeper issue of the problem that the researchers is trying to solve. But back to the core of your question, and I do understand that aspect, and that is it better to have number or quality? My answer is that you must have both. It's very important to have both. You cannot, let's say, work for 2 years just to have a one paper, but that paper is in, a very important journal, maybe the top journal. I know that he has worked for some of the awardees in my university. It has worked. So this person got the award because she has just that one paper that convinced the entire committee that she has got what it takes. But we also know that we are in a world where sometimes it doesn't fall in the right way, and therefore having numbers it will always be useful, right? It will always be useful to have numbers. So you should always have that strategy of having a very important work published in a top journal, but you must also have other so-called sidelines, other things that you work on, which is easily publishable and which will then create a better impression on the review panel. But I also want to add that having way too many papers could hurt you. So, because, it will give the impression that these young researchers have no commitment to quality. And he or she is just a paper machine, just churning out papers after papers after. So having too many papers. So if you have an applicant, say for a presidential postdoctoral fellowship, with 80 papers, immediately there's big suspicion, right? And I can share with you an anecdote. Someone with impressive number of papers, I think it was like 60 or 50 plus, impressed the committee sufficiently to invite this person for interview, right? at the interview, the members start asking, so about this paper, number 43, concerning this technique, can you tell us a little bit more about this technique that you did, and why did you choose to use it instead of other alternative? That person gave a very superficial answer. It was not deep enough to satisfy us that he knows his paper deeply, and he didn't get the award. So that is the anecdote that I can share. That whatever that you publish, you must know it. It's your own baby, so so you must know it.
Thank you. We've any questions online? If not, I know it's 2 o'clock already. We shall take some of these questions after this. So please join me to thank Prof. Khor for giving this wonderful presentation, and for all those ECRs, keep writing, keep publishing. The job doesn't end. Okay, thank you, Prof. Khor.
Thank you.
So while we're here, Professor Khor told me an interesting